Hello everyone, welcome to Computer 8. Today we are going to study about the signals and different form of it, how we represent it in time and frequency domain and so on. So let's begin. Information can be in form of data, voice, pictures, and when we transmitted it, it must be transformed into electromagnetic signals. Now signal may be represented either in analog or in digital form. This is an analog signal and this is a digital signal. Analog refers to something that is continuous. That means in every point we can get a value or we can get a data. For example, your voice when we speak, it is an analog signal. And so human voice. And for digital signal refers something that is discrete. For example, suppose you store some information into memory. So it is in the form of 0 and 1s. That means a digital data that is converted from a digital signal. Now, signal can be in the form of analog or digital, and analog signal is described by 3 characteristics. So we write analog signal. It is described into 3 characteristics. One is amplitude, then frequency, and phase. Now for a signal, suppose this is a signal. For this signal, this is the values and this is time. Amplitude refers the value of the signal in any point of time for any wave or signal. That means you can refer it also as the highest signal, means the highest point of the signal. This is also called amplitude. It is measured in volt, ampere or watt. Okay, now for a signal, this is a signal. For this signal, we can say the second characteristics, period and frequency. For this signal, this is called a period, means where a signal completes one cycle. This is one cycle, so this is called period. Now the frequency referred as number of periods in 1 second. So frequency means number of periods in 1 second. Suppose in the ear it measures amplitude, and in this axis this is time. Suppose this is 1 second. 1 second. Now in 1 second it complete 1 and 2 full cycles. So this is the frequency. So we can say frequency is 2 Hz. Hertz is the unit of frequency. Now period is inversely proportional to the frequency. So we can say period means time period equal to inversely proportional to frequency. Here frequency is 2, so time period is 1/2 second. Second is the unit of time or time period. Now the signal can be in 2 forms. What is signal? One is periodic. Now we know the concept of period. If a signal maintains a pattern within a measurable time frame, it is called periodic signal. it means a follow a pattern. Suppose this is a pattern and it follow a pattern, so it is a periodic signal. And a periodic, suppose in time amplitude format, this is a signal. You can say it cannot follow a pattern. That means a signal that constantly change without maintaining a pattern, that is called a periodic signal. So we can see a form of periodic and aperiodic signal, and it can be either analog or digital signal. Okay. Now we can also say a aperiodic signal can be decomposed into infinite number of periodic signal. Okay. Now take example. Here we saw a signal. Now we can find the frequency of it. So this is one cycle, or we can say one full cycle or a period. So one, this is 2, and this is 3 periods. So frequency of this signal is 3 Hz. Okay, so let's find the frequency of this signal. This is one period, second, third, fourth, or we can say fourth full cycle, fifth, that means 5. So frequency is 5 Hz. Okay, now this is 2 simple signals. If we compute, or if we overlap 2 simple signals, we can find a composite signal. Suppose this 2 signal overlaps. So how it look like? This look like that. That means another signal which is overlapped from this 2 simple signals. So here we can say that 2 simple signals are overlapped into one composite signal. Okay. Now this is a time domain representation. You can say it time domain representation. Here this axis is time and this is amplitude. In time domain representation, we can't explicitly measure the phase and frequency because it only shows the changes of the amplitude with respect to time. But if we measure in frequency domain representation, suppose here we represent frequency. In frequency domain representation, how we represent 1, 2, 3, 4 and 5, because frequency is 3 and 5, so maximum 5. So for this signal there is a frequency 3, so 1, 2, 3 here, and for this is frequency 5. Okay, and for this composite signal means it is overlap of 3 and 5, these 2 frequencies, so 3 and 5. In this way, as simple, we represent the frequency domain representation. Frequency domain representation. If you simply represent the frequencies of this signal, we can get the frequency domain representation. Now, suppose a composite signal contains a collection of frequency. Let's see. A signal contained a collection of frequencies. Okay, this is called a spectrum. This is called a spectrum. That means a set of frequency that makes a signal. That means a signal which have this a composite signal, obviously, which have these frequencies. Okay, so it is suppose it is a frequency of 100 and this is 500. That means it is the lowest frequency and this is the highest frequency. Now, the bandwidth refers the gap or interval between the highest and lowest frequency. So, bandwidth refers the gap between highest and lowest frequency. So, highest and lowest frequency. So, we can say 5,000 minus 1,000. So, 4,000 hertz, obviously it's the difference of frequency, so unit is hertz. Now for digital signals, suppose this is a digital signals represent in amplitude and time. So this is a digital signal. This is 1 0 0 1 1 1 0 1. Okay. Most of the digital signal are aperiodic. Thus the term period frequency there is not appropriate for that. So instead of time period means for analog signal the one total cycle. So in here this is not a period but we can represent it as bit interval. And for the frequency, for analog signal, frequency is number of total cycle or period sent in 1 second. Here, the frequency is represented as bit rate. The new term is bit rate. That means number of bits sent per second. So we can say number of bits sent per second. So this is called bit rate is equivalent to the frequency. Okay, now that is the third characteristics is phase. Phase describe the position of waveform related to time 0. This is the time axis and this is time 0. So we can say the position of the wave or the signal. So phase is the total phase or full phase is 360 degree. Okay. Now and period is measured in degrees. Now we can say if we shift, this is the total cycle. If we shift this portion, we can say 1/4 of one cycle. 1/4 of cycle. So if we shift this, okay. So we can say the phase shift of 90 degree. Phase shift of 90 degree. If we shift the half of a cycle, so in this way, so this is a half of the cycle, so we can say phase shift 180 degree. If we shift the whole cycle, so we can say it is full shift, that means full phase shift, that means 360 degree shift. Okay, so that is all about the signals. If you have any query, please ask on the comment section below. Thank you everyone.